Hello, good evening, everyone. So we have done the S block, P block, and the periodic table. So now we are going to do with the now we are going to start the revision of the first chapter, the mole chapter. We will be doing different numericals, and accordingly, you will be solving the questions in your exam. Right? So let's start. Okay. So the first question states, calculate the weight of zero point 0.1 mole of sodium carbonate. Okay, so how to solve this? What is the formula of the sodium carbonate? Right? So, number of moles. It is given weight by gram weight. Right? This is the formula. So moles according to the question is 0.1. Weight is not given. You need to find. What is this molecular weight of this? It is 106. So what will be the weight? Weight will be 106 into 0.1. So it is 10.6 gram. Okay, so this is your final answer. I hope everyone knows how to calculate the molecular weight. So just put those value and get the answer. So this is as simple as that. Okay. Coming to the second question. Let me check the second question. Yeah. The second question states that a carbon compound has 10.606, sorry, percent carbon, 0.84% hydrogen, and 89.1% chlorine. Calculate the empirical formula of the compound. Okay. So, atomic weight of carbon is 12. 1 for chlorine, it's 35.5. So this is given. So how to solve this? Okay. So just make a chart. Percentage weight, percentage by weight. Then percentage atomic weight. Divide with least value. So, and here is the name of the element. First is carbon. So carbon percentage by weight is given to be in the question as 10.6. What is the atomic weight? 10.6 divided by 12. So it will come as 0.84. So 0.84 divided by whatever will be the least value that. Okay, let's see. Second is the hydrogen. It is 0.84 given. So 0.84 divided by 4. It will be 0.84. Actual, yeah. So again 0.84 divided by what we have to see. Third is the chlorine. It's 89.1. So 89.1 divided by 35.5. It will come as 2.51. So among this, which is the least 0.84. So divide everything by 0.84. Here 2.51 divided by 0.84. It will 1, 1 and 3. Okay, therefore the empirical formula. What will be the formula? It will be carbon 1, hydrogen 1 and chlorine 3 or CHCl3. Okay, so this will be the final answer. Okay, so coming to the next question. Let me check the next question and let me give it to you. Okay, so there are two great questions. Not two, one great question. Okay, calculate the normality of oxalic acid solution containing 6.3 gram of H2C2O4 2H2O in 500 milliliter solution. Okay, so what is normality? So how to solve this sum? Just write the formula. Normality N is weight divided by summation of the gram weight, right? So multiplied by 1000 divided by volume. So what it is given? 6.3 divided by what is the molecular weight of this thing? It will come as 63. I hope you know to calculate the molecular weight of this. Divided by 1000 into 1000 divided by what is the volume given? 500. So this will come as 0.2 normal. So just apply the formula and get the answer. Okay, just you need to apply the formula and get the answer. Okay. Now, let me see the next question. Next, anything apart from this has not been asked. Okay. Let me check the other year's question. Again, calculate the weight of 0.1 mole of sodium carbonate. This is a repeating question. Okay, and then what are the next questions? Yeah. The next question comes as like this. A solution is prepared by adding 2 grams of a substance A to 18 grams of water. Calculate mass percentage. Of solute. So, mass percentage of the solute is weight of the solute divided by total weight of solution into 100. This is the formula. So what is the weight of the solute? What is the total weight of the solution? 2 plus 18 into 100. So it's basically 2 by 20 into 100. So it's 10%, right? So the answer will be 10%. It's quite easy. Okay. Next question. A compound has 4.07% hydrogen, 24.27% carbon, and 71.65% chlorine. Molar mass is 98.96 grams. Empirical formula. Okay, again, just now we have done a sum like this. So it will be a basic sum. First make the chart. Element, percentage by weight, percentage by atomic weight, and then is the divided by least value. Okay. Okay, so element is carbon, hydrogen, and chlorine. So it's 24.27. It's 4.07. It's 71.65. Right? So what will be it? 24.27 divided by 12. Here it will be 4.07 by 1. And here it will be 71.65 divided by 35.5. If you calculate this, it will come as 2.02. It will come as 4.07. It will come as 2.02. So what I told, divided by the least value. 4.07 divided by 2.02, it will be 2. 2.02 divided by 2.02, it will be 1. Okay? So what will be the empirical formula? CH2Cl, right? We got 1 carbon, 1 chlorine, 2 hydrogen. Now, what is the formula? If they ask you about the molecular formula, N is the molecular weight divided by empirical weight. So it's 98 by 49. So it's 2. So what will be the molecular formula? it will come as 2 into CH2Cl. So it will be C2H4Cl2. This is the empirical formula. This is the molecular formula. In your exam, mostly they will ask you the empirical formula. If they ask something about the molecular formula, just write like this. Okay, so this will be the final answer. Okay. Now moving to, okay, what is normality? They have asked a question is, what is normality? It is number of gram equivalent weights of solute present in 1 liter of solution. So they have asked the definition of normality. What is normality? What is the definition of the normality? It is number of gram equivalent weights of solute present in 1 liter of solution. Okay, this is the definition. Okay, coming to the next thing. Any other thing has not been asked in this chapter. Okay, if anything more have not been asked in this chapter, let's move to the next question paper. So, the question states, calculate amount of this is the question. Just try for once, whoever are seeing this video, just try for once. Once you have tried, you can easily tried. Okay, let me solve this for you. It will be C plus O2 CO2, right? 12 gram, 32 grams, 44 gram, right? So 16 gram will be producing how much? 22 gram. So this will be your final answer. Okay. Wow. What is the next question they have asked you? Let me see. Hmm. No, so far in the next year, they have not asked you any kind of the questions, but they have asked you questions about kinetic energies and everything. Okay. Apart from this, no other questions have been asked so far. Regarding the moon, whatever I have made you do, these are, I think, enough. Enough of the questions that you need to practice. Okay, one more question has been asked. 4 gram of NaOH dissolved in 250 milliliter of solution. Calculate molarity. So this is very easy. Just apply the formula and get the result. Right? Just you need to apply the formula and get the result. So what is the formula? Number of moles of solute, volume of solution in liter. So mass of NaOH divided by molar mass, right? Molar mass of NaOH. 250 milliliter means 0.25 liter divided by 0.25. So it's 4 gram divided by 40 gram divided by 0.25. It will be 0.4 molar. Okay. Now let's see what is the next question that has been asked to you. Next year, no question have been asked. It's basically the same question again. A carbon compound contains 12.8% of carbon, 2.1% hydrogen, 85.1% bromine. Molecular weight is given. We have to calculate the molecular formula. Okay. So it's just simple. It's just whatever it has been done so far. So, just wait for once. Molecular weight is given to be as 187.9. So calculate molecular formula. So it's an element. Percentage by weight. Percentage atomic weight. Divided by least value. Right? What is the element? Carbon, hydrogen, bromine. So carbon is 12.8. It is 2.1. It is 85.1. So it's 12.8 by 12, which will come as 1.067. It will be 2.1 by 1, it's 2.1. And here it's 85.1 divided by 80, it's 1.063, which is the least value this. So we have to divide everything by this. It's 1.067 divided by 1.063. It will come as almost 1. Again, 2.1 divided by 1.063, it will come to be as 0.98. And 1.063 divided by 1.063, it will again coming to be as 1. So the empirical formula coming to be as H1, H2, Br. And molecular formula is M. N of the empirical formula. This is the formula, right? Molecular formula is equal to N empirical formula. What is N? What is N? N is molecular weight divided by empirical weight. So it's 187.9 divided by 94. It's 2. So, and given molecular weight is 187.9. This has been given in your question. So therefore, what is the molecular formula? It's 2, this 2. 2 into CH2Br, like this CH2Br. Just multiply this by this. Okay, so it will come as C2H4Br2. So this is your final answer. Okay. Okay. This one question we have done already. A, if something more has come, same type of empirical formula, molecular formula. They have asked for you quite a lot of times. I have made you do this at least for 3 times today. I'm not making you do it again. So this is all the sums from the moles and the molecular formula that has been asked in your exam so far. Okay. Okay, one more question. This question. This is a good question, but easy question. How many moles of glucose are present in 540 gram of glucose? How to solve this? How many moles of the glucose are present in 5 moles of the glucose? Just try for once. Moles. This is number of moles, right? N stands for number of moles. It is weight whole divided by gram molecular weight. So it's 540 glucose C6H12O6. If you calculate its molecular weight, it will come as 180. So it is 3. So answer will be 3. Okay. Okay. If there is any more question, let me see. There are a lot of questions that has asked you to calculate the empirical formula. Make sure you can do it. I have made you do a lot of times in the class. So not doing it again and again. No more questions have been asked. That NaOH question have been asked, like what is the molarity of the solution? 4 by 40. That question has come quite a few times. So make sure you can do that sum. Okay, make sure you are able to do that sum. Okay. So these are all the sums that I have marked from your previous year questions from the parts. Apart from this, no other question has come. Yeah, so these are all the questions. Yeah, these are all the questions that you need to do. Okay, there is one more sum. This is a good sum from a titration. From titration, calculate the volume of 0.1 normal H2SO4 required to neutralize 200 milliliter of 0.2 normal NaOH solution. It is an acid-base neutralization reaction. Okay, so at the neutralization point, remember, so this is an acid-base neutralization sum. So at neutralization point, number of equivalents of acid will be equal to number of equivalents of base. Okay. So the formula is N1V1 is equal to N2V2. What it is given? 0.1. What is the volume? We don't know. 0.2 into what is 200, right? So just calculate V1. It will be 2 into 200. That will be coming as 400 milliliter. So this will be your final answer. So that's how you are going to solve the acid-base neutralization questions. Okay, this is all the thing that you need to do. Okay. Okay, so this was from my end. These are all the types of the questions that you will be getting from the stoichiometry part. I hope you like this. Thank you.